Hello everyone, today I'm going to explain A2 logarithms and exponential functions. So firstly, let's formally define the logarithm to be if you have y is equal b to the power x. This is the same as writing x equal log base b, so that's the base of y. So this is our formal definition of a logarithm. We're going to use this in cases where we want to change a statement which has log to a statement which has indices only with no log. All right, so here of course x will be an element of real numbers, y is an element of real numbers, and it's also positive here. Right, some other useful laws which we are going to look at in our solving equations is that if the base log any base 1, it gives 0. So that this is the first one. The second one is that log base b, if the base is the same as the number here, then this equal 1. All right, so we're also going to use this in our expansion in our solving equations. The second thing we want to look at is our laws of logarithm. Laws of logarithms. Right, so these are going to be our tools when we solve equations which have logarithms. Right, so the first one is that log any base here, x times y, is the same as log x plus log y. So this works in any base. Right, number two, if you divide log x over y here, this will be the same as log x minus log y. Right, number three, log any base x to the power n would be the same. So here you can drop down the power here, and this is the same as log that. So this will be true for any base. Now you will remember that in most cases we are using base e. All right, we are using base e, and remember, if you punch on e on your calculator, this is a value like 2.71828 going on like that. So, and if you have got log base e, and that this is like ln e, which is 1. So log base e x is ln x. We call that ln x, and you find the ln button on your calculator. It's a function on your calculator. Right, so we're going to incorporate all these, importantly the first one, and then these as well when we solve questions which involves logarithms. So we're going to do a few questions like from past papers, and then see how we're applying these. All right, so we're going to do examples on how to use the laws of logarithms as we just did. We're going to do a set of the first 3 set of examples that you can get. So the first type is when you have logarithms on either side. So our main aim here is to make sure that you bring this there. But the first question is show that you can write this as quadratic. So I'm going to move this over to that side. So this moves over to that side, and I'll have log 10 x plus 5 plus log base 10 x equal 2. All right, so I make sure that I've got terms in logarithms on either side. Now I'm going to use the law which says if you are multiplying, you add. So I'm actually using this first law here, which says if you're multiplying, you add. So this becomes log base 10 x plus 5 equal 2. So I've used that law to combine the two terms in logarithms. All right, now from the definition, I saw that I can rewrite a statement with logs to a statement without logs. All right, and remembering that this base is the one that raises the 2. So this is going to be x plus 5 equal 10 squared. I know 10 squared is 100, so x plus 5 equal 100. I remove brackets and then take the 100 on the other side. X squared plus 5x minus 100 equals 0. So there we go. I have expressed that as an equation, a quadratic equation. Right, My part 2 says, hence find the value of x after you solve that. So you see that this is exactly the same equation. So what we're doing is just coming back to what we have already. So we are going to solve x squared plus 5x minus 100 equals 0. We are going to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. My a is the coefficient of x, which is 1. My b is the coefficient, sorry, a is coefficient of x squared. B is the coefficient of x, which is 5. C is my constant term, which is minus 100. If you substitute this into the quadratic formula, then you see that you get x equal 7.81 or x equal minus 12.8. All right, so this is my first example here. I'm going to look at a closely related example. All right, so in this second example, it's closely linked to the first one. You want to solve this given equation here. So like the first one, we need to combine terms in ln so that they come on one side. So this is plus ln x. It goes the other side, it becomes minus. So we now have ln x plus 2 minus ln x equal to 2. So we've managed to bring the terms in ln on one side. We use our second law, which says if you're subtracting, then you divide. So we're going to have x plus 2 over x equal 2. So we combined using the second law. Now remembering that ln is the same as log base e, and using the definition of logarithms, we can convert this to a statement without logs. So this is log base e x plus 2 over x equal 2. So this e raises up the 2 according to that definition. So x plus 2 over x is equal to e to the power of 2. So the e raises up the 2. Now we need to make x the subject. I can cross multiply here. X plus 2 equal x e squared. I combine the terms in x so I can bring either this x this side and the 2 that side. So I would have minus 2 equal x minus x e squared. So I'm just bringing on terms in x on one side. I then need to factorize here. So if I factorize, I have that. I'm avoiding rounding off early because I want to round off the final answer to 3 decimal places as stated by the question. So I divide by the brackets. I get minus 2 over 1 minus e squared, like that. And if I punch that in my calculator to 3 decimal places, I would have x equal 0.313. So that's your second example. So like it's the same technique. You bring the ln on the other side, then you start using your laws. All right, I'm going to my third example, which is almost similar to this. So this technique of answering this sort of questions is almost similar. I want to show that that can be written as quadratic. Again, I need terms in logs on one side. It's minus in here, it adds. So this is x plus 5 plus log base 10 of x equal 2. So it goes there, it adds. The first law says this multiply. So log base 10 x by x plus 5 equal 2. I can rewrite this as a statement without logs. And of course, this I can multiply. So x squared plus 5x equal, the 10 is the one that raises the 2. So I have x squared plus 5x minus 10 squared becomes 100 equal 0. All right. So again, it's the same technique. Bring the terms with logs on one side. Use your first law to say if you're adding, you multiply. Rewrite this as a statement without logs, and then you go. It's like that. The second part says find the value of x which satisfies. It's the same equation as part 1. So basically, we are solving this here. So we know this straight goes to that. There is no need to simplify again because we've done that in part 1. So in most of these questions, check if there is a link between part 1 and part 2. Right. Here we can apply the quadratic formula, plus or minus b squared minus 4ac, everything over 2a. We can see that our a, which is the coefficient of x squared, is 1. Our b, which is the coefficient of x, is 5. our c, which is the constant term, is minus 100. If we do that, we get x equals 0.372 or x equal minus 5.372. So these are the two solutions that you are going to get. So this is my example 3.